All right, so now what we're going to do is we're going to do the exact same thing we did in the last video. We're just going to assume that we do not have a calculator, and we're going to perform uh, or we're going to construct the t-interval by hand, essentially. Um, well, I've done most of the calculations anyway, because some of them get a bit intense, but that isn't to say they can't be done without a basic scientific calculator. So again, first thing we need to do is get our critical information. So we see for our first sample, our sample mean was 80, sample standard deviation was 5, and our sample size was 26. For the second sample, the sample mean was 74, sample standard deviation was 6, and the sample size was 32. And what we're going to do is we're going to take that information and come over here to our formula that we have for a confidence interval. The formula, as we got from the notes, it's the two sample means subtracted from each other plus or minus a critical t times a standard error, where the standard error is just the sample standard deviation for the first one over sample size, squared over sample size, the sample standard plus the sample standard deviation of the second one squared over the sample size, and then that whole quantity square rooted. So 3 pieces to this. First, the the standard error. Then we also have the difference between the two. That will probably be the easiest thing. I'm not going to break that down very far. And then the hardest part of doing this by hand is this part right here, the critical T with its degrees of freedom. As you know, a critical T depends on a specific amount or a specific degrees of freedom. Before, the degrees of freedom was simply the sample size minus 1. However, for this, the formula for the degrees of freedom for 2 means is this complicated formula here. I'm not going to spend time doing this calculation, but essentially it's the same. It's the sample error, the standard error, but squared instead of square rooted, and then that quantity divided by 1 over n minus 1 for the first one, and then times the standard error over the sample size squared, and then that squared again, and then plus 1 over the second sample size minus 1 times standard error of the second one squared over sample size of the second one, and then that whole quantity squared. So this is a lot. This is why you wouldn't normally do this by hand. It's not fun. But when you go ahead and break it down and plug everything in, this is what it looks like. 5 and 6 go there, N1 and N2 go there, and once you simplify everything, you get 55.9, which will round down to 55, because as you know, we like to play things safe, so we don't want to do that. All right, so we have the degrees of freedom. Now what we need to do is go ahead and find the critical T based on that degrees of freedom. So if I flip this over, I've got my critical T value table. I know I'm using a 95% confidence level, and I know my degrees of freedom is around 55. However, I don't have 55 in here, so we go to the next one down, or I guess up in this case, the next lowest value, and we find where these two meet, and they meet right here at 2.021. So what that tells us is that our critical T that we're going to use for this confidence interval is 2.021. All right. Now, that was the hard part. That was the part that is absolutely the worst, which is why this is not something normally you would do by hand. But now that we have that out of the way, the rest of it's pretty straightforward. Calculating standard error for 2 means isn't that complicated by comparison. All we have to do is plug in those values that we had before, and we see that our standard error is 1.44. So we have this for the standard error, we have this for the critical T. This is just 80 minus 74, which is, 6. So when we plug everything in, we have 80 minus 74 plus or minus our critical T 2.021 times our standard error 1.44. We see that when you simplify that, it's basically just 6 plus or minus 2.91. So this would be our difference of our two means. That would be our statistic, and then this would be our margin of error. When you put that in the format that we prefer, we get 3.09 as the lower bound and 8.91 as the upper bound. And when we compare that to what we had before, that's pretty bang on. So not bad. We did it by hand, and we got pretty much exactly the same thing we did when we were using the calculator.